this is the very important session because now we have exam on. So student, actually, the planning of revision courses. Basically, first of all, we will discuss the linear algebra and linear algebra. Then after we will discuss the integral calculus. Then we will discuss the group theory. So basically, first of all, we will discuss some of the most important theory, like some revision theory, revisions, and then thereafter we will discuss the most difficult question series. I have created some questions for you, and these questions are most difficult means that these questions are new and have some new concepts. Basically, new concept means the concept which are interlinking. Done. So we will discuss. So as I think you have received the timetable as well as the sheet in which, like, what is the topic today we will discuss. So today we are going to discuss the topic, very, like, very basic topic. This is subspace, and this is also very important, basic and but important. So today the topic name is, we will discuss subspace, subspace, linearly independent oblique linearly dependent set, basis and dimension. So this is the discussion of today, number one. And tomorrow we will discuss linear transformations, eigenvalues, eigenvectors, and diagonalization. Then we will have three sessions. Sessions one, that is MCQs sessions, four is MCQ sessions, and fifth is also MCQs. So this is the 5-day schedule for, this is the linear algebra schedule. So do you know these things already? Yes. Do you know these things already? Yes or no? I think you know. फटाफट बताइए. So just speedily you can tell me. Yes, do you know all these things? Very good. Done. So please be focused. First of all, I'm going to revise the subspaces LILD and basis and dimensions. Okay, if you don't know about that, so this is the schedule of first 5 lectures. Then after that, I will give you the lecture series, the topic which is in integral calculus, and the same is in the group theory. Done. And if you have any doubt, you can ask me also. Yes. So student, the number one topic is subspace. You know vector space, you know subspace, but I am just going to revise what are the subspaces. The subspace, if you have a vector space V, F is a vector space, then W is a subset of V, is called subspaces if the W is itself a vector space over F. Basically, condition is, you know, condition, this one, A alpha plus B beta belongs to W for all alpha beta belongs to W, and for all A comma B belongs to field. This is called two-step test, and if you take one-step test, that is alpha plus beta W belongs to W and A alpha belongs to W, where for all A belongs to F and for all alpha beta belongs to W. You know this kind of things. This is the definition of vector space. And so this is the definition of subspace. And now you can also think about what is like how to prove that a subset of a vector space is a subspace. Okay, I will give you some examples, but before starting this one, I want to tell you one question. Like, can you say R square is a subspace of R cube? Yes or no? This is true or false? R square is a subspace of R cube. Yes. No, no. I asked you. So please keep mute yourself, all of you. Okay. Yes. So this is not a subspace. So many students will say, sir, this is a subspace, but I am saying this is not a subspace. Why this is not a subspace, student? Because you must know about that key the operation in R square and R cube, or like this is a subset of R. This is subset of R square, is subset of R cube or not. Basically, R cube is the structure of R cube is like XYZ, where XYZ are real number, and if you take the subset of like R square, the subset R square, this is X comma Y such that X comma Y belongs to R. So you can understand this point. Am I clear? So this is not a subspace. Subspace means you must have the subset first of all, then over the same operations and over the same like same field, you have to prove that that is a vector space. So for proving that one, you need to prove only that these two conditions. One condition is this one, either this or you can prove this one. Am I clear? No. So we can say you have number one. If I say MNR with respect to addition and dot, that is whatever is a vector space. Number two, can I say that is SLNR is a subspace of MNR? This is true or false? SLNR simple linear group हम कहते हैं, simple linear group type. Okay, SLNR is, and that is a subspace or not? Yes. How many of you say this is subspace? See, what is SLNR? SLNR is set of all matrix from MNR such that determinant of A is 1, and this is a subset of MNR. Student, can you tell me one thing? I think you have forgotten all these things. This does not has 0 SLNR. So how can you say this is subspace? So proof for proving subspace. This is one of the most wonderful questions. Basically, when you study the group theory, and group theory, you know this is a subgroup, but you must understand the concept key, the concept of group and concept of vector space somehow different, because at that time you had proved that this is a subgroup under multiplication, but here the multiplication is not defined. We are only discussing about the addition operations, and you can say this is not a subgroup. Yes or no? This is not a subspace. Am I clear? Why this is not a subspace? Yes or no? Am I clear? So how did you write down? Yeah, that was you were saying this is a this is a subspace, but I am saying this is not a subspace. Yes, this is a false statement. Next is the GLNR is a subspace of MNR. GLNR is a subspace of MNR. W is a set of all MNR matrix from MNR such that M transpose yes, this is a subspace, true or false? Tell me. What is the answer of number 3? Number 3? Number 3. Is it a subspace? Number 3 is not a subspace. Very good. Because GLNR also has the GLNR is the set of all n cross n matrix, real matrix, such that determinant is non-zero and zero does not belongs to the GLNR. It means this is not a subspace. Yes. What about fourth? Achha, fourth is true. Okay. What about fifth? What about fifth? This is also true. And sixth, this is also true. Yes. Very good. Done. Okay. So if you go next, that is seventh. The W is set of all those matrices MNR such that summation Aij is 0, I is equal to 1 to 1 for all I. And if you take this is the A belongs to MNR, so that summation Aij is 0, where J is equal to 1 to N for all J. These are subspace, yes or no? These are subspace, yes or no? Question number 8 and question number 9. Sorry, question number 7, question number 8. Musbu, you are asking 6 one? This is a subspace, yes. This is, sorry. What I have written, sorry. All these are subspace. This is true. What about this one? See, student, I am giving you I am just teaching in this, I am teaching in this manner. Why? Because we have already done all these things and we are discussing, we are just revising. We are just revising. So you cannot say, sir, like, कि explain कर दो ज़्यादा. Explain मैं कर सकता हूँ, I can explain, but the main thing is कि this is on the revision mode. So are you comfortable? All of you are comfortable? Yes or no? All of you are comfortable? Yes. Any problem to anyone? Very good. Very good. Done. So these are also subspace. Next. Now, when you have a subspace, then you can find out like subspace. Then you can find out some set. Set is Li or Ld or not. Okay. Achha, do you have any problem? Do you have any problem in subspace? Finding out whether a given set is subspace or not. Going forward, LILD set is set S contains alpha 1 equal to alpha n. All these are n vectors from a vector space V is Li if a1 alpha 1 a2 alpha 2 an alpha n is equal to 0 implies an equal to 0. Done. Otherwise, set is called LD. So this is the option, like set is called LD. Okay. So if you see this kind of things, so can I say like we have a set S. S is a subset of like 1 1 1 1 2 3 and 1 2 4. This is a subset of R3. Is it Li or LD? This is Li. Very good. So this set is Li. How to check this set is Li? How to check this set is Li? Basically, we have discussed one technique with you. That is, if this is a like a rectangular matrix you can form. Basically, you can put this is as in a matrix vector row wise, and if this is like this, so not determinate is the second things. First of all, you have to understand if determinant is not zero. So you can see basically determinant zero or not zero is not like not for all set, because set can be like simply set can be like set can form a matrix of n cross n or like n cross n. So basically we have to find out the rank of this matrix. We have to find the rank of this matrix. If rank of a matrix is equal to like this power, okay, dimension of r cube, that is 3. Sorry, what I'm saying, this set is Li or not. Sorry, the set is Li or not. If you want to find the rank is 3. The rank is 3. It means this set is Li. What is the meaning of the rank is 3? Basically you must understand like you have only 3 variables now, not by the dimension. Dimension is something different concept. Basically, if you have like number of variables, so how many number of variables are here? The number of variables, if you introduce like a, b and c, so 3 variable introduced, so number of variables are 3. So you can say this set is aligned. Okay, but give me answer of one question. The question is, if you have a question set as 1 1 1 1 2 3 1 2 4 1 2 4 0 1 1. This is a set of subset of R cube. This is Li or LD? This is Li or LD? Actually, if you say the number of element in a set is greater than the dimension of a set, dimension of a space. So basically, the number of element, the cardinality of S is greater than the dimension of a vector space R cube, which is equal to 3. It means this set is always LD. Basically, the we can say maximal Li subset of a vector space is basis. Is basis. Yes, is it clear? Is it clear? आपको सब बात clear है? Okay. And what is the meaning of dimension? The dimension meaning is, first of all, you have to understand the concept of basis. So basis means you have a set S, and S contains n elements that is called vector, and this is a subset of a vector space V. S is basis if number one, S is Li and Ls equal to V. It means S generates vector space Vf. It means every element of V can be written as a linear combination of element of S. ठीक है, यहाँ पे एक लाइन डाल रहा हूँ मैं, that is uniquely. Then you can say this is a basis. Basis means if every element of vector space V can be written as a uniquely the linear combination of element of S. This is called basis. So you have understood what is the meaning of basis. LILD said what is what is the meaning of subspaces, vector space. So all this kind you know. And what is the meaning of dimension? The dimension is, you must understand the dimension also. The dimension of a vector space is number of element in basis. So dimension is number of element in basis. So that can be finite or that can be infinite. So we have two type of vector space. One is finite dimensional vector space. Finite dimensional vector space. The example is Rn. Okay. एक होता है infinite dimensional vector space. Number of Li bases that is depend on, like, you have Li bases, you can form the infinitely many bases if you take the set of real numbers or complex. Number of infinite dimensional vector space, that is a PR. PR is the infinite dimensional vector space, and you are asking the number of Li bases. See, basis is always Li. Number of Li bases, there is no question. The number of bases you can ask. Number of Li's, like basis is already Li. Equal number of Li bases equal to no number of linear independent bases. No. Number of element in basis is called like cardinality. Cardinality is equal to dimension. But I'm saying the cardinality mod as dimension, that is dimension only. This is the main thing. Okay. Am I clear, Pranshu? Any student has, please repeat basis, sir. Okay. See, basis means if you have a set which is Li, linearly independent, as well as that can generate the vector space. The generate means every element of vector space can be written as a linear combination of element of S, and every element can be written as a linear combination uniquely. Then you can say this is a basis. I can give you example. Yes, I can give you example. The example is, if I say S equal to 1 0 and 0 1, this is a basis of R square. This is a basis of R square because this set is always Li. This set is number one Li. Number two, this set generates. Okay, R square. Why R square? Because any element xy can be written as x times of 1 comma 0 and y times of 0 comma 1, the linear combination. Am I clear? Yes. So one question, can you give me the answer? One question, that is some question I am just giving you random questions about subspace, matrices, all these things, mixing questions, because right now we have to understand the mixing questions. Yes or no? Yes or no? Basically, my question is, what is the determinant? What is the determinant of this matrix? Actually, this matrix determinant is 1 or या फिर -1. What is the exact answer? One confirm. Basically, I want to tell you one like new technique. This is also old technique, but we have not discussed. Okay, because we have discussed in some other way. Now we have some other technique also to find out the determinant. Basically, if you want to find out like determinant of 0 0 0 0 1 0 0 0, how will you know that your answer is correct or not? You have to do one thing. This is determinant. See, do you know determinant? If you change the row, determinant is multiplied by -1. Yes or no? Determinant is multiplied by -1. So if you this row and this row, if you exchange, so what I will get? The first row is okay. You what I am going to do? I am going to change the row so that we will get the identity matrix on the determinant, and you know that the identity matrix and determinant is one. Okay. So switching, you can do the switching. So we have swapped this one. So one is swapping, then -1 you will multiply. Okay. And one more, this is no swapping. If you swapping this one also, so this is -1. So can I say, if you swap, this is element -1, and this is nothing but the determinant of identity matrix? Yes or no? Am I clear to you? Yes or no? Yes. So am I clear ki how basically we have discussed one recursion formula. The recursion discussion we have done by the help of recursion we have done, but now without recursion you can also use this theory. So basically, if there is some question in IIT JAM 2022, like you have a question, and in this question you have to find out the determinant, and you know very well known example of like identity matrix, some kind of identity or some kind of diagonal and opposite diagonal, this kind of things. If you want to find out the answer, so how you will find out the answer? The answer is very simple, just swapping the row and you will find out the answer. Done. And you know some rules ki if you swap the row, or column, then the answer is multiplied by -1. Okay. And if you swapping the row is okay, if you multiply by one element k, if you multiply by k, yes or no? If you take one row outside, one element common, that will multiply by k. Yes or no? That is also clear. This is the rule of the determinant. Third is, if you add the row R1 to R2, the determinant does not change. Do you know these are the elementary row operations? Basically, we have discussed earlier, the elementary row operation does not change the rank of a matrix, but can change the determinant. Yes or no? We have discussed the theory, the elementary row transformations, elementary row transformations, elementary row transformations cannot change rank of matrix. Yes or no? Rank of matrix. But it can change. Determinant, trace, adjoint. Am I clear? This kind of theory you know. But if you do two swapping, one row swapping here and one more swapping, then then you can say the determinant is same. Am I clear? Yes or no? One swapping means you are multiplying by -1. Two swapping means you are multiplying by -1 and -1. So you have to understand this concept. Second concept is if you have like you are we have three row, one is R1, one is R2, one is R3. This is 3 cross 3 matrix. Let us consider. If you say the determinant, if you do second matrix, one is this is A and this is B, that is R1 plus R2. So what is the determinant of this matrix? Determinant of B is equal to, what is the determinant of this matrix? Yes. Same as determinant of one. One नहीं होगा बेटा. The answer is A. Why? Because determinant of B is equal to determinant of the answer is 0. The answer is as determinant of. Am I clear? So I am just giving you a brief of like some theoretical concept. Okay. Yes. If somebody is asking the question like A is 100 cross 100 matrix 0 0 0 0 1 0 0 0 0 2 0 0 0 0 0 3 0 0 and that is 100 0 0 0. This matrix, what is the determinant of this matrix? Yes. One is saying 100 factorial. One is saying 50-50. 100 factorial. Plus ये minus. Minus ये plus. This is the main problem. Yes or no? Y plus. Pakka. Even number plus, odd number negative. Can I say like this? Even number plus or odd number negative? Odd order. Wrong. The answer is wrong. Even number plus and odd is negative. This is wrong. See. This answer may be right or not. We will check. But first of all, I have asked this even number plus and odd is wrong. So if odd is wrong, the answer must be -1. But our answer is if you swap these two only, the answer is -1. Even order negative. Even order negative. Pakka. देखो 3 order. 3 order only one swapping. The answer is this one. So answer is -1. This is odd order. Odd order. Am I clear? Odd order. पीछे आ जाते हैं. Odd order positive. Odd order positive. So what is the conclusion? Is there any conclusion? Can you give me some conclusion? Yes or no? Sometimes we are saying odd order positive, sometimes we are saying even order positive. So you have to check. You have to check. Okay. So direct even order negative. If even order negative, every time even order negative. See, if you take 6 by 6, what is the answer of this? This is like no 100 factorial. Sir, odd number of switches negative, even number of switches positive. Yes. So I think you are getting my point. Okay, no problem. But one more question. Basically, we have discussed all these things. What is the dimension and all these things, and in dimension subspace. But in this subspace dimension, we have used the concept of matrix. So matrix theory is also useful, and there are so many questions on the matrix theory in this exam, IIT JAM. So can I say one more thing? Let us consider let P and Q are two matrix of order n with determinant of P is non-zero, no, determinant of P is 1000. ठीक है? Let M be any non-zero matrix of rank n0 non-zero n cross n matrix with rank r of rank r. Then rank of PMQ is rank of PMQ is I am giving you 2 minutes for this question. Just think and tell me what is the answer. Manoj is saying, sir, answer is R. No, n is not equal to R. No. And maybe R and may not be R. See why the answer is R. Answer is R. That is okay. But why answer is R? Minimum of n into R. Who told you? Who told you? No. This is one of the concept that is no. See, do you know number one theory? Row oblique column transformation. Column transformations are called elementary transformations. Elementary operations, oblique transformations. Row or column transformation are the elementary operations or elementary transformations. Okay. So whenever you have some problem, like we have one problem 1, 2, 2, 3. If I convert into this matrix like R2, we are going R2 minus twice R2. So what I will get? I will get 1, 2, 0 minus 1. Yes or no? So basically, when you do some row operations, so can I say कि basically you must have studied this theory कि this is a matrix B, then B can be obtained by some elementary matrix E1 into A on the pre-multiply of E1. What is E1? The E1 is given by E1 is a matrix, is a elementary matrix obtained from identity matrix by applying same row operations. Am I clear? Do you know this thing? Yes or no? Do you know this thing? Basically, you can do find out. You can find out what is E1. The E1 is R2 minus twice R1. So R2 minus twice R1 minus 2 R2 minus twice R1. That is it. So if you multiply B E1 into A, you will find out this. Okay, done. And basically, and one more thing, if you apply some column operations, if A is a matrix and you are doing some column operation like C1 is C1 minus C2, let us consider you are getting B matrix. So B is equal to A of C1, where C1 is a matrix. Like you are getting the matrix C1 by applying same column operation on I. Do you know this thing also? Do you know this thing also? So basically, if you want to find out the second matrix, then second matrix is the pre-multiply of the elementary matrix to the A, and second matrix, what is column? The column is nothing but the post multiply of elementary matrix of the same column operations. Done? Done? Chali. So we can say, let us consider we have this problem. So you can understand the problem like we have this 1, 2, 2, 3. Okay. What we are doing? We are doing R1, sorry, R2 to R2 minus twice R1. Okay. 1, 2. So basically, this is a invertible matrix. What is this? This is invertible matrix. What is my planning? My planning is the invertible matrix. You can convert it to the identity matrix by applying column and row also. Okay, column and row, you can do this thing. So if I say C2, C2 minus 2C1, if I do this one, then you will get 1, 0, 0, C2 minus 2C1. Okay, then finally, if you do R2 minus R2, then you will get identity matrix. Yes or no? And it means what I can say, we can say the matrix, this is a matrix like you say the matrix P, this one identity, the P matrix, the identity matrix, you can say the P. Why so P? We will say this is the identity matrix. So this matrix can be written as, see, first of all, what you have done? Like this A, okay, this A पर लगाएंगे हम रो. पहले कौन सी रो लगाएंगे? पहले ये वाला ऑपरेशन लगाएंगे. This is one operation, number 1. Okay. Then further you have applied second operation on the right. Then this further left. Can I say कि A पर पहले लगाया मैंने first operation, the first matrix आ गई. Okay. And further you will apply on the left hand side, no, right hand side, the second operations. ये matrix आ गई. Then first you are applying third operations. So you can say I is equal to 3, 1A and 2. What is 3, 1A? 3, 1A is called the 3 is the third elementary row matrix. And first is also elementary row matrix, and 2 is the elementary column matrix by applying the same operations. So basically identity you are saying, okay, or you can say, I can give you the example. You can also say ki every, basically what I have done, this is a equal to 1 inverse, 3 inverse, identity 2 inverse. Yes or no? These are 1 inverse, 3 inverse, 2 inverse are inverse of elementary matrix. And what is elementary matrix? Elementary matrix is a matrix obtained by single row oblique column transformations on identity matrix. ठीक है, आइडेंटिटी मैट्रिक्स पर अगर कोई भी ऑपरेशन लगा दे तो हमारे पास बेसिकली मिल जाती है. तो मैं ये कहना चाह रहा हूँ, बेसिकली दिस इज आल्सो एलिमेंट्री मैट्रिक्स. So you can say this is, all these are elementary matrix. The inverse of elementary matrix is also in elementary. So you can say every non-singular matrix can be written as a product of elementary matrix. The product of elementary matrix. Okay. So you can say, if I am saying you are multiplying a non-singular matrix to a matrix B. Okay. This is a matrix, any matrix, and you are multiplying, pre-multiplying, a post-multiplying. So you are doing the elementary row operation. There are so many elementary matrix you are applying on the left. So an elementary matrix means elementary row operations. Elementary row operation does not change the rank of a matrix. Elementary matrix does not change the rank of a matrix. So there is a theory. This is the theory which is developed by here, by this rule. If we apply non-singular matrix, multiplication of non-singular matrix does not affect the rank of matrix. Basically, because these are the product of so many elementary operations. So my question was, what is the rank? The rank is exactly R. This is clear to all of you. If you have doubt, so you can do one thing, you can ask me this question. You can ask me this question. This is one of the most important question, but this kind of question can be asked in the JAM. Any other student, any student has any kind of issue, please let me know. Yes. If you have any kind of issue, you can let me know. No doubt. Very good. So do you have any doubt in subspace, vector space, linear transformations, all these kind of things? Otherwise, what I will do, if you don't have any doubt, if you have any doubt, we can discuss. Okay. Otherwise, what I will do, see here. This topic is complete. Okay. We will do complete some topic in this one, and tomorrow onwards we will have more and more questions. We will discuss tomorrow onwards. We will have more and more questions. Characteristic polynomial, all this kind of things will be in eigenvalue eigenvectors. Okay, so I think, so should I start the topic number linear transformations? What is intersections? Any letter. See, any letter of a subspace, any letter or any later polynomial. What you are asking, Thanu? One is called intersections. Intersection of subspace. Any later polynomial. Okay. So you have doubt. One is, I am just writing, and he later subspace. No, any later polynomial, not subspace, because subspace is not the dimension. So it syllabus. Any later polynomial. Number one. Okay. Next question is intersection of two subspace. Intersection of. See, I will discuss some theory here and discuss the question. I will discuss theory here today. Okay. And you are asking some more question. Dimension of W1 plus W2. Okay. So I will discuss the theory here, and we will discuss more and more question tomorrow. Okay. Yeah. In the question series, MCQ series. Done. Any other doubt you will have? This is characteristic polynomial. Genus. Characteristic polynomial. Genus. Any other student? Any other things you want to say something? Minimal polynomial. Okay. So this is the main thing. Yeah. Minimal polynomial. Minimal polynomial. Any other thing you want to discuss? Yeah. Okay. Diagonalizable matrix. Okay. Diagonalizable matrix. Diagonalizable matrix. These are. Any other questions? Any other theory which you have doubt? In which you have doubt? Tips for finding. Tips for finding what? Tips for finding good marks in IIT JAM. Tips how to get a good marks in IIT JAM. Do study and do study and do study. Eigenvalue Eigenvector. Okay.
Sir.
Yes. Yes.
सर ये पूछ रहा था कि जनरली कुछ क्वेश्चंस आते हैं कि व्हाट इज द आइगन वैल्यू ऑफ दिस वेक्टर ऑफ दिस मैट्रिक्स, मतलब a माइनस लैम्डा आई, तो उससे हमें इसकी वैल्यू मिल जाती है लैम्डा की। लेकिन सर उसके बाद हम आइगन वैल्यू तक कैसे पहुंचे सर? ये चीज एक मुझे आती नहीं है सर।
Can you give me some question?
सब क्वेश्चन मतलब जनरली मैंने जब सॉल्व किए थे तो मतलब कैरेक्टरिस्टिक इक्वेशन रहती है सर, मतलब वो होती है a माइनस लैम्डा आई, मतलब जो आपका मैट्रिक्स a माइनस लैम्डा और i तो हमें मालूम है आइडेंटिटी मैट्रिक्स, मतलब 1 1 इक्वल्स टू 0, तो इससे लैम्डा की वैल्यू हमें मिल जाएगी। लेकिन सर उसके बाद लैम्डा को फिर वो लैम्डा तो हमारा आइगन वैल्यू हो गया सर, लेकिन आइगन वेक्टर कैसे?
Okay, Eigen Vector, how to find out Eigen?
यस। और सर एक क्वेश्चन आया था लास्ट ईयर मेरे एग्जाम में, जनरली वो था a equals to 2000, 2021, 2022, 2023, मतलब हर एक रो में उसका एक एक नंबर इंक्रीमेंट हो रहा था। फिर ठीक से सर वो क्वेश्चन मैं आपको बाद में बताता हूँ।
मुझे क्वेश्चन दे दो, मैं अभी डिस्कस कर लूँ।
2021 का है सर।
आइडिज्म?
यस सर।
डन। सो मुझे क्वेश्चन दे देना, मुझे क्वेश्चन भेज देना, वी विल डिस्कस। चलिए। So many problems you have can be done by elementary operation, can be done by elementary operations. See, if you do only row operations like R2 minus R3, R3 minus R1, the determinant does not change. If you multiply by something, determinant change. If you exchange the row, the determinant change. Am I clear? Aniket is saying whatever question is like Dinesh is saying, then you can find out the answer by using the elementary row operation. See, elementary row operation change the determinant. That is okay, but elementary row operation cannot change the determinant when you add R2 is R2 plus R3. The determinant is same. So you can do this kind of things. Okay, yes or no? This kind of things you can do. And second is elementary row operations. If you exchange the row, the answer is multiply minus 1. So as soon as you will do some operation, multiply, minus 1, minus 2, you can do this kind of things. Okay, am I clear? And if you do, if you multiply by 2 in any row, then multiply by half in the after. Yes or no? This kind of things you can do. Done. So I think Aniket is also saying the same thing. You can also do a genius, and if you have difficulty in that problem, you can send me the problem. We'll discuss the problem at the end of the class. If you can send me right now by the help of Eduncle support team, or we can discuss tomorrow also. Done. So we have discussed these things. The subspace Li subspace done, LILD done, base is done, dimension done. The question is how to like subspace like W1 plus W2. So W1 intersection W2. Basically, see W1 plus W2 is a subspace. Basically, W1, W2 are two subspace. Then W1 plus W2 are the subspace. Is that subspace where alpha belongs to W1 and alpha 2 belongs to W2. This is also a subspace of V subspace. And this subspace W1 plus W2 is generated by W1 union W2. This is generated by, you can say generated by. This is generated by. Right? And you can say the dimension of W1 plus W2 is equal to dimension of W1 plus dimension of W2 minus dimension of W1 intersection W2. This is the main theory of the dimension theorem. And dimension of sum of two subspace you can find out. Okay, this kind of things. But how to solve the problem? There are so many questions how to find out, like a sum of two subspace dimension, how to find out the subspace, like intersection of two subspace. What is the, there are so many questions like what is the minimum value, what is the maximum value, what are the possibility of W1 intersection W2. So we will discuss in the MCQ series. So I have note down your problem, what kind of problem you are facing. See, I'm already done. So this kind of theory we will discuss. So this kind of problem we will discuss in the MCQ session. Done. Now you have a problem on linear transformations. So linear transformation, I think you don't have any problem. But for Firbi, I am just explaining you what is linear transformation and how to find out the answer. Linear transformation, eigenvalue, eigenvector is saying eigenvalue, how to find out eigenvalue, eigenvector. Okay. Okay, done. See. In linear transformations, you must understand one thing. T is a mapping from vector space U to V. U is a finite dimension vector space, finite, infinite, infinite, finite, infinite, infinite, finite, anything. Then T is a linear transformation if T of A alpha plus B beta is equal to A times of T alpha plus B beta. Okay. For all alpha beta belongs to U, and for all A comma B belongs to fill in. Now the main thing is that, what is the main thing? The main thing is you have to find out the range space, null space, and find out, you will find out the rank of linear transformation and the nullity of linear transformation. Rank and nullity of linear transformation. Do you have any problem in this topic? Range space, null space, rank and nullity. And one more thing, the dimension theorem, that how by in the question the dimension you don't have any problem. So I am just saying if U is a finite dimension vector space, U to V, and U is a finite dimension vector space, then you must know the rank nullity theorem. The rank of T plus nullity of T is equal to dimension of U. Okay, yes. What he's saying, my answer was correct, but took some time. Question is, what is the order of the matrix? Dinesh has given one question like 2021, 2020, 2020, 2020. Only 4 by 4 matrix? 21, 20, 20, 20, 20. 21, 21, 21, 20, 20, 21, 21, 21, 21. Haji, can you convert this matrix into upper triangle matrix? An upper triangle matrix, the row echelon form upper triangle matrix has determinate. The determinant is upper triangle matrix determinant is the product of diagonal elements. So can you apply the row operations? We know the row operation we cannot apply because the row operations say हमारे पास determinant change हो सकता है. But whatever determinant we will change, we will find out. We will find out the determinant and we will multiply the respective factor outside also. Done. So just try. Okay, try करते हैं. If you do R2 minus R1, is there any problem? If I say R2 minus R1, any problem determinant? No. Yes or no? Yes or no? Can you say this thing? This is okay. R3 minus R1 and R4 minus R1. Any problem determinate? 2021. 1. That is 0 minus 1 0 0 0 minus 1 minus 1 0 0 minus 1 minus 1 minus 1. Yes or no? Am I correct? Now what you can say? What you can say? What is the answer? The determinant is same, na? Yes. What you can say now? Answer is yes. With respect to this column, if you multiply, see. No, answer you know, but what is the logic? The logic, can you tell me what is the logic now? See, if you take this one, 2020, this is this one, the determinant of this one, that is only minus 1, minus 1, minus 1. This is upper triangle, lower triangle matrix. The answer is determinant is minus 1. Yes or no? If you take this one, you will have this row 0. If you take this one 0 0, the answer is minus 2021. Can I say answer this one? 2021 or minus 2021? Student, just find out, am I correct or not? 2021 pakka. What is the fault in my question, my answer? Is it any mistake? Is any mistake? Last row I have done some mistake. What is the last row? नहीं मैं नहीं कह रहा, whatever question you have written here, my answer is wrong. Okay, maybe wrong, but is there any mistake? What is the mistake? Can you find out? कौन बताएगा? स्पीकर पे आ जाओ. Result of operations are instead of one. Pransu is saying result of operations are one.
सर
Yes.
सर एक्चुअली जो R4 है उसमें 2021 है और R1 अगर माइनस करेंगे तो पॉजिटिव 1 आएगा ना.
ये सब पॉजिटिव आएगा. Yes or no? So this kind of mistake can be done here. मैंने जानबूझ के करी है, पता ही है तुम्हें मेरे बारे में. I was checking ki who is serious. Yes, most of you are serious. Very good. Very happy to see this. Yeah. So this is clear, na? This kind of things. Jinesh, is it clear? Jinesh, am I clear? Done. Going back. How to find out the largest eigenvalue? Yes. Who will tell me how to find out the largest eigenvalue? The next doubt is eigenvalue eigenvector. ये question में wrong हुआ था. Li, linear transformation, okay. Block matrix we will discuss. Eigenvalue eigenvector. Minimum polynomial, characteristic polynomial, this kind, sum of two rows. Sum of two rows is same. Sir, my doubt. What is your doubt? Samarity? What is your doubt? What is your doubt? Yes, Samarity. Yeah, you can ask me. I have problem that if we know all about transformation T, then how I relate? I send you message. Which message you have sent me? I have problem that if we know all about transformation T, then how T square T square all? It will be related to T square T square. No, T square T cube you can find out. Yes. What is your in rank related theorem? If dimension U contains M cross N matrices, then for dimensional U, we have to take maximum M. No. If dimension U contains, then U is the set of all M cross N matrix. U is the set of all M cross N matrix. What is the dimension? No, dimension is not minimum of M and N. Dimension, you have to check what kind of vector space you are taking. Yes. No. Largest eigenvalue, who will tell me how to find out the largest eigenvalue? If some of the row is same, then the values are largest. See. Just tell me some questions. अभी बताता हूँ, wait. 1000. Yes. What is the eigenvalue? What is the eigenvalue? Maximum eigenvalue. Yes. What is the eigenvalue of this one? Yes. Acha, what is the row sum here? 1. What is the row sum here? 2. What is the row sum here? So we can say the row sum, the eigenvalues. Can I say this one? Have you ever studied eigenvalue of a matrix lies between 1 and 3? maximum eigenvalues. Can I say like this? No, this is not right. This is not right. This is not right. But as Aniket is saying something, some other person is also saying. Wait. If row sum is same, if row sum is same, then row sum is one of the eigenvalue. If row sum is same, then row sum is one of the eigenvalue. And that is the row sum is called largest eigenvalue. This is some proof. There is some proof of this question. So row sum is same, then that is the one of the eigenvalue, and that one of the eigenvalue is largest. This is same as column sum also. You can verify this result and you can tell. Yes. Am I clear? Now the main problem arises from your topic, the eigenvalue eigenvector. The eigenvalue eigenvector. What is eigenvalue eigenvector? The eigenvalue, you know, ax equal to lambda x is called, if A is a square matrix, if A is a square matrix of order n cross n, then if ax equal to lambda x, then lambda is called eigenvalue. X is called eigenvector. This is called eigenvector. This is called eigenvalue. Done. So you know eigenvalue eigenvector. What is the meaning of eigenvalue eigenvector? If ax equal to lambda x. So basically, A has a eigenvalue lambda and eigenvector x. Then you know a square has eigenvalue lambda square, eigenvector x. A की power r also has eigenvector x and eigenvalue lambda raised to power r. Next step is A inverse has eigenvalue lambda inverse and eigenvector x. And same thing is for adjoint of A. So these are the matrix which has same eigenvector. Adjoint of A has same eigenvector x and eigenvalue determinant A upon lambda. All these things you know. If you know these things, then we can say if you know how to find out the eigenvalues, then how to find out eigenvectors? Eigenvectors is ax equal to lambda x. What is the solution of ax equal to lambda x? Let us consider you have a matrix A is equal to, let us consider 1, 2, 2, 3. Simple problem. And like not this one, I am saying 1, 2, 0, 0, 0, 1. And what you are saying, sir, basically the lambda is equal to 1, 1 is the eigenvalue. So what is the eigenvector? So I will say ax equal to lambda x. So basically the solution of ax equal to lambda x implies a minus lambda I of x equal to 0. It means a minus I of x equal to 0. So a minus ai x equal to 0 means a bx equal to 0. What is bx equal to 0? This is a system of homogeneous system of linear equations. So if homogeneous system of linear equation you have the homogeneous system of linear equations, the solution are called the eigenvectors. And you know that in homogeneous system of linear equation bx equal to 0, the number of like solution can be unique or infinite. So a unique means if determinant of B, like rank of B is full means basically this is a square matrix. So you can write down if determinant of B is non-zero, okay, it means that A minus I determinant is non-zero. So that is unique. If this like this, okay, infinite if determinant of B is 0, it means determinant of A minus I. So you can say like this, you can say, okay, you can find out the number of eigenvectors, whether the eigenvector is unique or not. And in the similar case, you can find out the how many eigenvector are linearly dependent, how many eigenvector are aligned. Li. The how many eigenvector Li? That is the n minus r, where n equal to number of variable, no, but r is, see, the rank of a minus lambda I, not a, not a. Please note down. The rank of b is asking. Okay, that is rank of b is the rank of a minus lambda I. So these are the main questions. Okay, am I clear? So you can find out easily. Your name is see, what can I say? Dinesh. So you can find out the eigenvalue eigenvector. Any problem?
सर
Yes, yes.
सर ये तो समझ गया, लेकिन आप एक बार शॉर्ट में एक बता देंगे कि मतलब क्या क्या टिप्स रहता है कि मतलब जैसे कैरेक्टरिस्टिक पॉलिनोमियल से हमें मिल जाएगा आइगन वैल्यूज, फिर मतलब ऐसे ही आप ओरली एक स्टेप्स बता दीजिए सर, मतलब नॉर्मली।
क्वेश्चन क्या है?
सर अभी जो ये सर अभी जो ये दिया था, मतलब ये आइगन वेक्टर वाले ही अभी
नहीं, बेसिकली स्टेप में प्रॉब्लम है
सर। कैरेक्टरिस्टिक पॉलिनोमियल के बाद को सॉल्व करने के बाद आइगन वैल्यूज मिल जाता है। मेन मुझे यहाँ से ये क्या बोलते हैं, आइगन वेक्टर को सर्च करने में प्रॉब्लम आ जाती है कि मतलब उसका फॉर्मूला एक क्या रहता है, कि जैसे मतलब हमें लैम्बडा मिल गया, हाँ
see, just give yourself.
सर मुझे ये छोटी सी चीज में प्रॉब्लम रहती थी।
Yes, this is the problem.
ओह गॉड सर समझ गया, मतलब कैसे वो करना है।
ठीक है
गॉड सर ये तो मतलब वो कहते कि 100 में से 95% कर लिया था, ये सिर्फ 2 या 3% का मतलब
सिंपल, this is simple.
ओह गॉड
चलिए
थैंक यू सर।
you can sure.
एक सेकंड सर, मैं इसका स्नैप
Now you can do in the same manner, like ax equal to lambda x, ax equal to lambda x for 1 also, like a minus lambda I of x equal to 0. So what you can do, a minus I, because lambda is equal to 1 is also there, a minus I is so these are Eigen vector. You can find out the number of linear independent eigenvector also, or number of eigenvector also. Done. Okay. So eigenvector eigenvalue is clear. Okay. Yeah. Next is basically you have matrix. You can find the eigenvalue eigenvector, and you know basically if you have matrix A n cross n, so a minus lambda I is equal to 0 is called characteristic polynomial, nahi characteristic equation, and this is called characteristic polynomial. Okay, and finally you can say this has exactly n eigenvalues. कोई पूछ लेगा how many eigenvalue has, at least, at most, this kind of things exactly. So you can say this is exactly n number of eigenvalues we will have of a matrix A of order n cross n. Done. This is the problem. But how many eigenvector, independent eigenvector, we don't know. We have to find out. And this is a concept of diagonalization. So we will discuss diagonalization also in the next days. So the one question we have, just give the relation. One question is also there. Let us consider you have a matrix A. Okay. A matrix. Okay. This is H2 cross 2 matrix such that A square is equal to. My question is, how many characteristic polynomial exist? See, my question is how many characteristic polynomial exist? So you have to think about this question, but I just discuss. Generally, student, what the student think? Student think this is the idempotent matrix. And idempotent matrix are infinitely many. अगर determinant 0 है तो infinitely many, you know. If determinant non-zero, the unique. So you know कि if matrix is given, the matrix is given, then you can say the characteristic polynomial is unique for a matrix, because for a given matrix the eigenvalue are unique. If eigenvalue are unique, then you can find out the characteristic polynomial by the equation. Okay, lambda minus first lambda minus lambda 1, lambda minus lambda 2 up to lambda minus lambda n. You can find out the characteristic polynomial. So characteristic polynomial of a particular matrix is unique, but you have infinitely many idempotent matrix. So generally, student, what the student write down? The student can write down answer. इसका आंसर क्या है मैंने लिख दिया 1. Student say actually sir characteristic polynomial is unique, so only one characteristic polynomial exists. Answer B is 2, answer C is 3, or answer D is infinitely many. So most of the cases student write down either this or this option. Yes or no? Because infinitely many cases, infinitely many matrices of 2 cross 2 exist. So it means the characteristic polynomial are only infinitely many. Yes or no? Yeah, for some student thinks a characteristic polynomial of a given matrix is unique. Okay. So if you give me matrix, idempotent matrix, if I take a idempotent matrix, then answer is unique. But my question is, the answer is neither one and nor infinite. The answer is something else. Can you give me the answer right now? Can you give me the answer right now? The answer is absolutely answer correct is 3. So all of you have to think why the answer is 3. And we will discuss this question tomorrow, and we will discuss this question as well as we will discuss some more problems, some more theory of diagonalization, eigenvalue, eigenvector, minimal polynomial, annihilating polynomial, intersection, all these things we will discuss tomorrow, and matrix theory. Okay, this theory we will discuss, and on the next session we will discuss more and more problems on linear algebra. Is it clear? Manoj, can you tell me how the answer is 3? How the answer is 3? Manoj, can you explain me? Just 1 minute. फटाफट बता दो so that we can close this session.
सर आइगन वैल्यू 0 और 1 होगा, दो ही आइगन वैल्यू है.
ठीक है.
आइगन वैल्यू या तो 0 होगा और या 1 होगा. ठीक है. तो लैम्डा माइनस 1, लैम्डा माइनस 1 और लैम्डा माइनस 0, लैम्डा माइनस 0 और लैम्डा माइनस 0 या lambda minus. Very good,
very good. Yes, this is the concept, and this concept we will discuss more clearly in tomorrow. I think most of you have understood the concept of Manoj Kumar. Manoj is saying absolutely right, and this is the concept of similar matrix. It means they are infinitely matrix, but in this infinitely matrix, only 3 distinct. The 3 matrices are similar. Like okay, 3 set are unsimilar, otherwise all the matrices are similar. This is the concept like isomorphism. Isomorphism, you see there are so many groups of like particular order, but we can say up to isomorphism, how many groups. So in the same order, you can find out how many similar metrics up to how many non-similar metrics up to isomorphism. So you can say non-similar how many. So this is only 3 and 3 characteristic polynomial, distinct characteristic polynomial exist, and root are either 0, 0, 1, 1 and 0, 1. That's so. Thank you very much for today's session. I hope you understand my point and you got some benefit for today's class.